All right, so hello and welcome. Oh boy, I think I'm going to turn down the volume a little bit because I'm going to speak louder today. Yeah, so, oh, there is, oh, I don't even know what to say. We'll just say I struggle. I struggle. Let's put it that way, I struggle. Like so many others, I struggle. But anyway, this problem I wanted to, oops. I wanted to look at this again. By the way, we finished the first 100, so that's good. Nice. Also 667, so we're almost a third of the way there. Making progress. I want to solve some of these problems. So what I wanted to talk about specifically with this question is this is actually not cubic time. I was thinking about it. It's like this should be faster, the solution, and it's not cubic time because it's slow, right? I said it's cubic time before. It's not cubic. It would be faster than this if it was cubic. It's quartic. And the reason it's quartic, and I was thinking about like how do you assess that this is quartic? Well, the reason it's quartic, it would be each of these variables, right? These three that you're looping over, a, b, and length, are looping from 0 to roughly 30. And there's also an inner loop here that's linear. So it's the number of loops, like, and these would be nested loops, the number of nested loops plus each of the variables. That's how you get quartic rather than cubic. So it's cubic memory, but quartic runtime. So that's kind of important. It's a detail that I missed the other day. I wanted to say that there's another way to do this too, using dynamic programming. It should be a little bit more efficient. It would also be iterative instead of recursive. So we can say basically just an array. We can say int n is s1.size. We can say this is a const. And we can say we'll call it array 3 by 3 by 3. So it's an integer array of size n by m by n. And hopefully that works. I think that's fine. Yeah. And then we can say it's a nested for loop, multiple for loops that we're nesting here. So we're going to say for int k, we'll say the number of characters, or yeah, we'll do k, number of characters. This is going to be less than s1.size, less than or equal to, actually. And we're going to say plus plus k. And we're going to say for int a equals 0, a is less than s1.size, plus plus a. Int b equals 0, b is less than s2 size, which should be the same, plus plus b. And then we're going to say for int I equals 0. It's actually going to be, so I'll explain in a moment what we're coding here, but it's going to be the length of the strings, and we're going to potentially split those strings into let me think for a moment here. Yeah, it's going to be the number of characters on the left side, the number of characters on the right side. So we could do left. It's actually easier. Left, and that's going to be less than or equal to k divided by 2, which is interesting also. And I'll explain that in a moment with that why that is. But it's so if you had k is 4, you would do 1 character on the left, 3 on the right, 2 on the left, 2 on the right. And you wouldn't do more than that. You wouldn't do 3 on the left and 1 on the right. You don't need to do that. I think I could be wrong about that, but I'm fairly certain that's the case. If I'm wrong, we could just remove the divided by 2 there. But the next part is if it was 5, you would do 1 on the left, 2 on the left, and you don't need to do 3 on the left. just do 1 on the left, 2 on the left. So yeah, divide by 2. It's 5 divided by 2 would be 0, 1, 2. Yeah, so not equal. Not equal. Doesn't need to be equal. 4 would be 0, 1. No, it should be equal. I'm sorry. 5 divided by 2 would give you 2. So 1, 2. Yeah, no, that's fine. That's correct. That's correct. Is equal. So now what you say is we have initial values, and these are actually booleans rather than ints. Got that wrong. I made a mistake there. So initial value, initial state for the DP is going to be hello. I was watching something else, but came to say hello. See you later. God bless you. Oh, I appreciate that. Thank you, Melito. Take care. Yeah, that's fair enough. Fair enough. I'm kind of just always going. So, yeah, definitely shouldn't prioritize me. Don't do that. Definitely should prioritize your own things that are going on. This is going to be, let's just say A. So the initial state. So basically, what we're doing is we're unrolling this routine. We're going for, instead of going top down, we're going bottom up. So we're going to start with these cases that these are true from A equals 0 to or when A and B are equal to each other. So A is less than s1.size plus A. B is equal to, excuse me, s2.size plus B. Could say const c1, or we'll say x, const character x is equal to s1 of A. Y is s2 of B. And we're going to say array of A, B, 1 is equal to true. If is actually equal to x equals y. So it relates to just s1a equals y, s2b. That's the initial state. And then we say dp. I don't really have much more to say here than that. And so array of A, B, it's going to follow A, B, and K are going to follow the same rules. A, B, and K. It's going to be, there's 2 ors and 2 ands in here, these 2 conditions. And it's going to be the, what we have here. So array of, this is A, B, K, and F. A, B. So this is kind of tricky. So we have, when K is 2, so actually this starts off at 2. This doesn't go to 1. This is never 1. We actually initialized 1 here. What we're going to say is basically we're going to loop through every string of size 1, every pair of strings of size 1, and save in our memory whether or not those pairs matched, or whether or not B could be a scramble of A. And then what we're going to do is we're going to say, okay, now look at K equals 2, all of the pairs of strings that are size 2, and check if the string of size 2 from A could be scrambled into the string of size 2 from B. Or I think it's the other way around. I think it's the, is whether, oh, no, oh, no, I didn't mean to do that. Thank you, LeetCode, for saving that. Whether or not the string B starting at index B of length K could be a scramble of A, right? That's what we're going to do that for when K is 2, that's going to be one loop. Now the way we do that is we say take the string that starts, so the way we do that is we say, okay, the string that we're looking at that starts at A could be split into two pieces, and if those two pieces could be scrambled, then that means that that scrambled into B. Let me just think for a second here. Yeah, could be scrambled into the correct pieces for B. Then then we can select that portion. It's a little confusing. I think actually I think I do need to do it this way. I think I do need to go this way. I'm sorry, there's one piece here. It's hard to describe exactly what it is. Part of the issue is so if you can split A into two pieces and both of those pieces could be scrambled into, so let's say there's split into two pieces called x1 and x2, x of 1, x of 2, x of 2. X of 1 could be split into the corresponding section for B, and x of 2 could be scrambled into the corresponding section for x2 or for B as well, right? So there's sort of also splits B into two pieces. If that's true, then a scramble is possible. Or if that portion could be scrambled into, and you can reverse the two pieces, right? So you could scramble it into the right side of B, and the right side of A would be scrambled to the left side of B. Now, the reason why I'm saying that we don't need to go through all K possible splits is because you only have to go through half of them, is because you're moving the pieces, right? So if you can move this piece here and then try the piece on the other side, making this first portion larger and checking it, and then also checking it on the other side, is that different? Like, in other words, I think that case is already covered. You know, I could be wrong about that, actually. I think I'm wrong. I don't think it's true. I don't think it's true because the problem with that is the left piece, as you make it larger, it's not going to be the same piece. Yeah, actually, yeah, you do need to cover the whole thing. I was wrong about this. It's not going to be the same piece. This is a tiny optimization, by the way. It's not really a big optimization, but it does make it technically would be twice as fast. But the reason why is that piece that you're on the left side, the more characters you add there does actually matter. It is different from the right side. So okay, so that was wrong. Okay, anyway, but yeah, so you could say this is going to be the left piece matches. You can scramble the left piece and you can scramble the right piece, right? Which is K minus left. So A to B, or A left matches B left, and then it's actually going to be A plus, I think we did this before, right? So it's A plus, which is bool C1, or B1, or yeah, or do X, just do X and Y. X and Y. And we're going to set this to X or Y. And that's all. And then you just return at the end. Array of 0, 0, 30, s1.size, or n. Also, this should be, yeah, that's fine. Hold on a second. Oh, that's interesting. I gotta think about that for a moment. This should actually be n plus 1. Yeah, because we're doing, yeah. That's fine. We could do n plus 1. That's not a big deal. Because k is incremented by 1. It's 1 index upwards. K is the number of characters. But anyway, so A plus left is where A is going to start now, and B plus left is where the B portion is going to start. And the number of characters is going to be K minus left. Right. And then on the other side, A left, B left, you want to actually match the section of A on the left side to actually a section of B on the right side. So that's actually going to be add. So I did this before. It's K minus left, which is confusing. And then these change too. So it's on the A side, it's A plus left characters matching to B shifted over K characters to the end and then shifted to the left characters. So B is off the edge and then you add those characters back. That's the index that B starts at, and it goes left characters. And then so that's the split from A to B. And then the other side is starts off A plus left, and it's K minus left characters, but B is now on the other side. Now B is starts from the beginning of B, right? So you swap these two, what these are pointing to. I think this works, and give this a shot. Yeah, that's kind of involved. Runtime error. Invalid bool. What? What's going on? Runtime error. Load of value 4, which is not a valid value of type bool. Oh? That's weird. What's going on here? Say true. What happens if we do that? Does it compile or run to runtime errors? 255. Maybe the issue is that I need to initialize this data. That could be the problem. True. Okay. It could just be uninitialized data. I wasn't expecting that. I thought booleans were sort of 0 to begin with, but yeah, we could initialize this with, I think you could do something like this. I don't know if that works. We could try that. Or false it should be. 1, 2, 3, 4, 5, 6. I don't think I saved my test cases for that. I didn't for this the other day. Variable size object may not be initialized. How do I initialize to 0? I mean, you could do like a standard fill, right? Right up again. I don't think you can. No. Do I have to do this manually? CPP fill an array with initial values. How does this work? Huh. Not a good fit for Q&A. Okay. Fill. Oh, I forgot. Okay, you could do standard begin, standard end. Interesting. We could try that. Forgot about that. Okay, what does this look like? Oh. Does that not work? Array designators. Huh. Unspecified but well-defined behavior. Initialized to 1, 2, and 2, 2, 1 are both valid. Undefined behavior. Wait, what? I was just trying to do this. Valid C, invalid C, but valid C++. How come I can't just do that? I guess because it's a multi-dimensional array. Now, these are things I should know. Variable sized. Oh, because it's variable sized. Oh, I see. Oh, I see. Okay. Okay. Initialize a variable sized array. I don't know. How do we do this? This is new to me. It's new to me. Feels like I should know this, but just don't use it too often. I use vectors usually. That's usually. What's the question? I don't know. We'll come back to that. Size of array, use standard C to get static data. No, you can specify variable sized arrays. It's saying just use vector, but I don't want to use a vector. That's not. I want to initialize. Dummies. How come I can't figure this out from the docs? Yeah. No, that doesn't help either. All array elements that are not initialized explicitly are 0 initialized. It's not initialized explicitly. In some case, an object is 0 initialized. Those are. This is in C though. This is. That's so confusing. Arrays of known size and arrays of unknown size may be initialized, but not VLAs. Variable length arrays. Okay, I think. Oh, this can't be initialized. Okay. All array elements that are not initialized explicitly are 0 initialized. But they can't. Variable length array cannot be initialized. I see. So you won't be able to initialize it. All right, that's fine. I think we need to do something like this then. variable length arrays initialized set initial values. Well, that's not very clean. I don't like that. That's not very concise. Stack buffer overflow. Nice. Is it this that's causing the issue? True. True. Now this is really interesting. I'm glad we tried to implement this. Oh. So it is this that's causing the issue. Huh. Why is this causing such a problem though? Oh, so these are just N, and then again. Does this need to be? I don't know. Maybe is this necessary is the question I ask. I don't know. I don't know. Maybe. Is it random data? Is it initially false? The default value of a variable length array in C++. No default value. Uninitialized elements of the array will have unpredictable values. Okay. You have undefined behavior. Indeterminate means garbage. Okay. Got it. Got it. I think it's fair to say it cannot be initialized, therefore it must be basically garbage. Assumed to be garbage. So I think I'm correct. I think I'm correct. Freestanding implementation. So what's that? I think I'm correct by running this code. Hosted and freestanding. Hosted implementation with the set of standard library headers required is much larger. Freestanding may happen without an operating system. Oh wow, that's wild. Whoa. Code executed without an operating system. Whoa! Whoa! Not something I'm super familiar with. What's going on? What is load of value 255, not a value for type bool? How? What? Excuse me? What is happening in my program? What's going on here? Shouldn't these just all be false or true or something? What is going on? Excuse me? Huh? These are Booleans, right? What is happening? I don't know what's going on. I'm so confused. This is new to me. We'll just print all these values, I guess. How did that happen? Okay. What is going on? Okay, it's kind of annoying typing all this out, but I think it's correct. Pretty sure. I don't know what I did wrong. We will find out now. Okay. I think we'll put the first two on one line, and we'll put the next two on the next line. What does this do? Expected expression. What? Wait, what's wrong? What is going on? Oh, that's the problem. That's not supposed to be there. That's my mistake. I may have just made a mistake. I probably just made a mistake somewhere here. So load value 4. We should actually put a thing here too. Check. I guess we don't really need this either. That might be a little bit disconcerting. How are we doing on time? Half an hour now. We've looked at this. So 0, 0, 1, 1, 1, 0, 1, 0, all the way down, and then somehow we get nothing here. What? A plus left. Oh, I'm so dumb. It's my mistake. It's also my mistake. I completely forgot. That's a very slight thing, but yeah. So it would be less than or equal to n minus 1 minus k minus 1, which is just n minus k. Yes. Well, no. Yeah, you can convert those to indices. So I think, is that right? Is that true? Doesn't seem right. No, still wrong. I think these are just decrement k. That's confusing. Why that would be less than n? Because it was less than n. Oh, it's wrong though. Wait, what? How come? Yeah, we do equals. This doesn't work, right? The math on that, I'm not getting that right either. Oops. Yeah. If k, why would? Well, k is characters and n is characters. N minus k, characters minus characters. Yeah, I think that's fine. You just have to match. If you do indices, it's n minus 1 minus k minus 1. Same number. Anyway, so all right. Finally, we got the. It's funny. Finally we got the bounds of our routines correct, but the question is, I think part of the issue might be so we got false. Did any of these end up being true? Oh boy. Is it true? And we're going to say A, B, B, A, B, and then a left amount, we'll say. I don't know. Or maybe it's not left amount, it should be K, I think. Debuggery. The debuggery. Okay, why does this keep happening? Where is this coming from? So this, if I comment this out, then this gives us false, right? I'm so confused. Why does that keep happening? Oh, what? Somehow, is it just random data that we're getting? But somehow if I comment this out, then we run into issues again. I think the issue might be, because this time sometimes goes to 0, right? That might be why. That's really confusing. The values for, I mean, you could just set this to 0 too. I mean, that would avoid these things from happening, but there's some issues here. So I think this is always at least 1, right? So K minus left plus 1 maybe is the issue, or one of the issues. I don't know. Come back to that in a moment. Left can't be equal to K. That's probably one of the problems. Left can't be equal to K. That's one issue for sure. And then so we got false, says true, true, true. A is 0, B is 0, 4. It's true. Oh, okay. 1, 2, 3, 4. 1, 2, 3, 4. Okay, that's interesting. We don't get, what is N? N is 5, right? Brother, this ended up being way more tedious than I thought it was gonna be. I thought this was gonna be a very simple like translation, just 1 to 2. N is 5. So we want 0, 0, 5, not 0, 0, 4. But we got 0, 0, 4. Okay. So what happened with 0, 0, 5? What happened to 0, 0, 5? 0, 0, 4 worked out. We didn't get 0, 0, 5. How come? 0, 0 left. One. So this should 0, 0, 5 should have worked out because we should have gotten we never revisit any of these. No, we don't. We don't rewrite any of these at any point. You just only have to write them once. Right, every A, B, and K pair is different. So, well, oh, maybe not. Maybe that's the issue. That's kind of what I'm wondering. I'm wondering if it's should be this. That's another question that I'm having. Wondering. Still wrong. No, no. That actually doesn't matter. No, no, no. It doesn't. No, no. Oh, well, yeah. I mean, maybe this should be actually or equals. It really should be if it's not. You could put an if statement here if it's not true already. But this also would but that's not the issue. I mean, that might matter in other cases. My thinking is the reason that might matter is that like this could get like overwritten at different points because you have technically n shots or k shots at modifying A, B, and K, and so these could conflict with each other. But we just checked that the or equals doesn't make the difference here. That's not the problem. I think that maybe should be. Or is it maybe it's this one? Excuse me, invalid expression. I don't know if that's the right. Can I do it this way? There's this one. I don't know if I can do this. Bitwise arithmetic. Assignment. Operators. I don't think I could do it the way I'd like to do it here. Because I want to assign a logical assignment. Bitwise or assignment. Oh, overloadable. Maybe this is the problem and I don't realize it. Well, actually, it should work with booleans. Because a boolean actually is like an integer. It's just an integer with two, 0 and 1. So this should work, I think. Believe it or not. If you did this instead, I think it still works. Yeah, you get the same. That's fine. Should be logical, but anyway, doesn't matter that much, I think. But the point is somehow this is wrong. Why is it wrong though? Oh. So everything starts off at false. Initialize k of 1 to 1, or mostly, sometimes true. K less than or equal to n, 0, 0. So somehow when we check AB left, which one is supposed to match actually at the end here? Like we can go ahead and print these and see. Okay. Maybe we should print A and B also. A, B, and K. Yeah, this is quite the conundrum here. I don't know, not conundrum, but just don't know what happened. Don't know what happened. Oh, I see. Okay. You don't go through too many. A is 2, K is 2, B is 1, K is 2. Okay, that's all well and good. 0, 0 should be 0, 1, 1, 0, 1, 1. And then for 4, there's only really... So this should be equal, I think. Less than or equal to. What am I getting wrong with that? No, well, doesn't K... We don't call K of 5 anywhere, right? Because A... Oh, that's really interesting. Oh, this is... Yeah, this should be equal. This should be equal. Because you're... I had that right the first time. That's super confusing, but I had that right. So 0, K is 2, is 0, 1, and B is 0, 1. And then you go to B is 2 and 3, and there should be a 3 and 4 somewhere in there. Oh yeah, no, I was thinking that through before correctly. Oh, there we go. Why? Oh, what? And then what if we just did this? Is this the same thing? Oh man, it's quite the thing here. Yeah, I think or equals is better though. So let's try that. Yeah. This was supposed to be a little bit cleaner than it was. This took a while. This was supposed to be a lot faster, a lot cleaner. It took me almost an hour to work through all this issues. But yeah, this should be a lot faster than the recursive version because there are no function calls. It's iterative. It's doesn't use any tuples. Doesn't use a map. You don't create. The memory is just kind of in one chunk. You don't have to allocate all this memory. Yeah, the map doesn't use a container. All those things. Like there are a lot of pieces to it. So it's just a lot more efficient. And I think there were a few cases we had. How about these things? Try a bunch of stuff. All right, I think we got it. Let's see how it goes. Hey, there you go. That's the That's a lot faster. Told you. Told you. It's almost 100, almost optimal memory usage, and then almost optimal speed as well. That's kind of what I was expecting. So this is the same solution, just rewritten as a dynamic programming solution. I don't know if we can get better than, I don't know if we get 100%. I mean, almost 90% is pretty good. That's kind of what we want. But most, if not all, of the, yeah, there we go, over 90%. Now here's a question. Let's try this. Let's see if this is still correct. I don't think so, but we could try it. This would be a little bit faster. Oh, wrong. Yeah, as I thought. I thought it was wrong. Maybe though it's wrong for this reason. Oh. Uh-oh. Hey-oh. Oh. Okay. Yeah. Ooh. Yeah, I thought there was some case that it would be wrong on. That's, yeah, I mean we already went through that, but it's pretty much, it's probably as good as it's gonna get. We can maybe keep running this a few times to see if we can get I should really stop hitting the button when I'm not sure. It's a bad habit. Like I knew I had a case where, well, I didn't really think it through all the way. I was like, well, there's probably a case where this doesn't work if you do it wrong. But let me see. Now here's a good question. I think this will also cause problems. Here's another idea here. Yeah, there you go. So you do need to, so that's a case where you must initialize the values. Too bad there isn't like a very quick way of doing this though, a simple way. I don't know, man. How can I make this faster? That's the next question. Apparently there's a way to make this even faster. You could go, you could let k be even one less, and say subtract 1 from everything. Everywhere you see this, you could just subtract 1. Yeah. Could try that. I don't know if that makes sense. No. It doesn't make sense. Yeah. No. No, it doesn't. Can you do that? Super confusing, I realize. Yeah, that just confuses everything. You could decrement, yeah, we could try that though. I mean, we could try, that'd be 0, so k is 1, and so k is 0. That's might be slightly faster, slightly less memory, slightly faster. I don't think so though. So we could say, so now you decrement these by 1, and then left is no longer 1, it's 0 here, and then left less than k, well, k is decremented by 1, so that's fine. So I think we're okay. I don't know, it's confusing. That's confusing. Oh, now it's wrong, but how does this work? K minus left. Left goes from 0. Now left, I guess, could be less than or equal to K now. It's so confusing. All right, let's do it this way. Let's go back. Let's go back. The logic is too hard. Okay. Start off at 0. And it's going to be 1 minus, so everywhere you see K, you're going to subtract 1 from it. So when you subtract K here, you add 1. See K, you subtract 1. Right, so here you're subtracting K, but here you're less than K. And then where you see left, that also gets a minus 1. Let's get to plus 1 now. Oh, that's confusing. Oh, that is so confusing. Oh man, so everywhere you see a K, you subtract 1. But here you subtract another 1, and here you subtract another 1. And then here you subtract another 1. Oh boy. And you try something like this. Oh wow. That's wrong. This is too many. It's too confusing. It's too many spots. There are way too many spots. And actually subtract left by 1 also. Here. That's another 1. Oh, who knows? Who knows, man? It's too hard. It's way too hard. I don't know. In theory, you could translate that, but in practice, it's way too hard to think about. No. Let's try it. Let's try it. There's got to be a way. There's got to be a way. Right? There's got to be a way. Maybe I'm just wrong doing this. In my mind, I'm thinking, oh, wait. Well, now we're just wrong altogether. Whoa. What? Oh. Okay. Oh boy. Okay. So. All right, let's try it one more time. Let's try it one more time. So we're gonna. N is like so. N minus 1. 0. And we're gonna say, okay, for K is 1, K less than N, increment K. So K plus 1 is the number of characters, right? So if K plus 1 is the number of characters in the particular string we're interested in, then A is got to be, it's less than N is the index. So A is an index, but the number of characters is N, and N minus K plus 1 would actually put you at minus 1, right? So if K plus 1 is the number of characters, then we actually, if K plus 1 is the number of characters, then we want to subtract K plus 1 from N. So N minus K minus 1. From 0, so we go from 0 to, so like if K is 3, let's say, so 3 character string, No. K is 3 means it's a 4-character string. So A would only be 0 or 1, right? Yeah, which is 5 minus 4 is 1, 0, 1. Yeah, that's correct. Okay, so I got that wrong before. And then left is going to be the number of characters. That's fine. We could use that. But everywhere you see left, you would subtract 1. So we probably just should outright start off with, yeah, actually that's fine. And then this is going to be, the number of characters in left is going to be less than k plus 1. So it actually could be less than or equal to k. It's just confusing. We should do less than k plus, well, less than or equal to k. Let's do less than k plus 1. It's easier to think about. And so now we could say right, we do have to subtract 1 from left everywhere, which we could just as easily subtract left. So left now, it's not 1 character. Left plus 1 is the number of characters on the left side. And so now you could say left is less than k again. Right, because the number of characters, so k is the number of characters in the total string. The number of characters on the left side of that has to be less than, and left plus 1 is going to be, okay. And if we do this, then actually we end up with the correct calculations, I think. Does that work out? I don't know. It's super awkward. No, it's wrong now. Now it's wrong. Okay. Now it's wrong. What? I think the reason is because everywhere you see k, you need to actually use k plus 1. More or less use k plus 1. So now we have to rewrite. So A0, B0 left. I think that works fine. Right, that'll actually represent one more character than the left side. And then the number of, and then the right side, it's not A plus left, it's A plus left plus 1 is the index for A and B. That's a change. And then B plus k minus left. Well, left, if it's 0, the index you start at for B is you want left plus 1 characters from the right of B, from the end of B. So the index would be the size minus 1, and then minus left plus 1. Excuse me. Actually, I hadn't really thought about that. You could just do n minus left instead of these two calculations. Yeah, that's probably better. That's n minus 1, by the way. I didn't even consider that. Yeah, for B, it's n minus 1, that index, and minus left minus 1, or minus left plus 1. That's how many characters you want. So if you want 0 characters, you would do minus, so I think it's correct, you minus left. So yeah, 0 characters would be right there, or 1 character would go nowhere, and then, more than 1 character. So that's interesting. And then on the other side, you have A plus left plus 1 for the index. And B doesn't move. K minus left, yeah, that's super confusing, but I think something like this. I don't know. No. Oh, there's like so many different indices going on here. There's so much stuff happening. So for the first match, you'd have index 0. So the left side of A and the left side of B, they match for left number of characters. Plus 1. Well, yeah, left number of characters, we'll say. And then the right side of A, which is you can increment by left, which has got to be left plus 1. Is that right? Why would that be left plus 1? What's the index, right? Yes. Yeah, that's right. Yeah, you move that many characters over. That's the starting index. That's correct. These two are correct. How many characters now? We said it's k minus left characters, but k is no longer k plus 1 is the total of characters, and then k plus 1 minus left plus 1. So it is just k minus left for characters. That's so confusing. But that you have to subtract 1 again, because we're no longer measuring. Well, no, you don't. You don't actually have to. I was gonna say we're no longer measuring it by that difference. I think that's the part that's super confusing, is that if this is no longer one indexed, the number of characters that array, then you have to make everything 0 indexed. So that difference is still the same difference, but I think you subtract 1 because you're no longer 1 indexed. That's super confusing. I realize. Yeah, I think that's right, because you could end up in a situation where you never. That might be the only thing that's wrong. Let's try that. That's probably more than one thing that's wrong, though. Yeah, it's probably more things. But you could end up in a situation where the difference between k and left is the same, but because the array you're indexing is 0 indexed now, you still have to subtract 1. No, this is so painful, so difficult. Oh, it's great. This is great. Yeah, this is definitely like one of the upshots to using the recursive approach instead of the dynamic approach, is that figuring out all of the translations in the dynamic approach is just so confusing. It's just getting everything indexed properly is just like, oh, why torture myself so much? All right. So again, AB left, and increment the number of characters indexed for A and B to the right by adding the left side, and then also you're going to say the length of the character array at that point, which is k is the total of our string. K plus 1 is the total. Left plus 1 is how many characters on just been considered. But if you just do k minus left, that's the number of characters that we're considering. You still have to subtract 1 to get the right index for that number of characters. So I think this part's right at the top portion. This part is interesting. You would say you're going to try to match A and the left number of left plus 1 characters from A to B, and it's going to be from the right side of B, that left plus 1 number of characters. So now we're swapping, sort of there was like 4 different strings. You're going from 1 to 4 and 2 to 3 now, or 3 to or 1 to 4 and 2 to 3 instead of 1 to 3 and 2 to 4. So that's what X is representing: 1 to 2 and 2 to 4, 2 to 4, and we're now going 1 to 4 and 2 to 3. So that is the index is going to be n minus 1 minus left. Now what's interesting is that it's it's minus left plus 1 is the right. So that, yeah, this actually just ends up being n minus left. And the reason for that is n minus 1 is that rightmost index. And then if you wanted the index at the beginning of the string that had left plus 1 characters, you would subtract left plus 1 characters from that spot. So you go from n minus 1 minus left plus 1, which gives you, actually that's really confusing too. I think you get minus 2, which is really weird. Let me think about that for a minute. Also, wow, I'm noticing like I haven't really been hitting the gym much. My arms are getting kind of weak. Let's see. N minus 1 is the index, and left minus 1, left plus 1 is the number of characters. Subtract 1 from that, now you're working with indices. You usually want to subtract index from index. So you would actually, yeah, it should be n minus left. See, that's super confusing. But no, it can't be n minus left, because left could be 0 and n minus, yeah. So I think you have to subtract 1 from both. Or add one to left and subtract 1 from n. If you, yeah, see, I don't know, man. It's super confusing. It's so confusing. It's n minus 1 minus left plus 1, which actually gives you n minus 2 minus left. That is just so confusing. So confusing. Yeah. If left is 0, then this should be n minus 1. I think I had it right the first time. Left is 0, this should be n minus 1. Right? Because that's the last index on the right side. That's represent left, in that case, when it's 0 represents 1 character. I think I had it correct the first time. Super confusing, but I think I had it right. Now, same thing, a plus left plus 1, k minus left minus 1, but now so this should be right. Why is it wrong? It's just so hard to wrap your brain around it. It really is just too difficult. Let me do this. Let me go get the debug code that we had before, because that's what we need to pull that out. We need to find out what exactly is going wrong. Okay. What do we expect? So now we do expect 0, 0, 0, 1, 0, 2, 0, 3 should go to 0. Oh, that should go to 4. That B should go to 4. Oh, and K is 0. Oh, K doesn't start off at 0 though, does it? I guess it doesn't, because we set K equals 0 here. So we don't really need to go to K equals 0. So K equals 1, so that's basically 2 characters. So we would say 0, 1, 2, 3. It should go to 4 though. So I was wrong. What's wrong about this one? The bounds there. It's like I don't know, man. I can't do it. I can't do it without can't do it without oh no, it shouldn't go to 4. No, I was right. I had it right. Because if it's 2 characters from the 4th index is actually the end of the array. So that is nonsensical. So no, I had the right. It's so difficult. So difficult. Go up to 3. So A is 3, B is 3, K is 2. Yeah, that's fine, comparing those two to each other. And then eventually we get K is 2, we get K is 3. So when K is 2, right, we go through 0 to 3, should be 9 of them. K is 3, there should be 4 of these. A0, B0 was run a couple times. K is 3. Why do we do that twice? Excuse me. A0, B0, and K is 3. Oh, because left. Yeah, left was. Okay, we do that as well. Wow. Wow. Also, my glasses. I'm supposed to be practicing not using my glasses here. Oh man, it's so hard to read. I can see it blind as a bat without my glasses. I actually just can't see it. I'll try to focus here. Oh, brother. This is going to be really difficult. Well, that's frustrating. Maybe I can bring the screen closer to me. I have made a makeshift standing desk here, but the desk itself is actually, you know what? I can maybe, hold on, flip this around. Try that out. Hold on, because I moved the screen up a bunch. Oh, that works perfectly. That works fine. Ah, there we go. Sweet. Ah, okay. That's a little bit easier. A little more natural. Sweet. Okay. Oh yeah, no glasses. Here we go. That's a lot easier. Now I can see. Although now I'm like putting my face into the computer to see. But there it is. So, okay. So what we were doing was we had A0, B0, K1 all the way over to A0, B0, K3. We were saying now we have left as well. Excuse me. We should say there would be a few of these for K equals 3. Excuse me. So excuse me. So all the way at the bottom, we would want to say there's an A0, B0, K is 5, I want to say. Yeah. Oh. Also, we have too many test cases to work with here at the moment. Let me quickly do this. All right. We're also like way over time here. It's been a lot of time that we're using. It's okay, I think, but okay. So when k is 4, that's the one we're interested in, right? So 0, 0, k, left 3, left 2. Okay. So one of these should match on 4. 0, 1, 2, 3. Specifically, the one that we expect to match is 1, 2, 3, 4. So there's left 0, 1, 2, 3. 0, 1, 2, 3. And we would say GREA probably matches RGEA. I think this one matches with this one. So that would be left 3, and it's the first one on left 3. So yeah. So this should match A0, B0, A0, B0, left 0, or left 3 should be a 1. Right, because that's saying the first 4 characters, 1, 2, 3, 4, match the other 4 characters. So let's go to that one. That should be 0, 0, 3. And let me see. Yeah, 0, 0, 3, and I guess it would be, where is 0, 0, 3? Excuse me. So now which one, on left 0, left 1, or 2, do these match? 0, 0, 3. 0, 0, 3, it looks like it's similar. You can do left 2, or left 1 it would be. So 0, 0, left 1 should give you true. 0, 0, 3, left 1. So this is, everything is false. Alright, that's not right. Yeah, 0, 0, 3, left 1. But these two should be true, right? The first one, it's the first one again. So this one can be scrambled with this, and the second one is directly that one. So this second one so both of these should be true for the top one at 0, 0, 3, 1. So for some reason, both of these should be true, but for some reason they're both false. Oh no, this right one's true. That's correct. Or should be left 1, I'm sorry. 0, 0, 3, left 1. This should be true on the right, and this one should be true on the left. So that's 0, 0, 1. These two, and then the other one, it should be k is 3 minus 1. Oh, this is the minus 1. I got that wrong before. It is this idea that I had before about it being 1 indexed. I was correct. I was correct. Oh no. Well, oh. Oh, these need to be fixed too. Okay. Plus 1, plus 1. Okay, I see the problem now though. These are totally different now. Yeah, I definitely have like some of these wrong somehow. That's gotta be it. That's gotta be the thing. Just didn't properly map these indices correctly for some reason or another. Okay. Okay. See how much easier it is if you just use, if you just make one of your arrays one index. It's so much easier to think about. If you try to make them all 0 index, then you just get so confusing. All right, so actually my analysis was just wrong before. 0, 0, 4, left 3. Still incorrect, but the 1, 2, 3, 3, 4, and 1. So this one should still be a 1. And the one on the right is a 1. Nice. That still begs the question, that one. So that was 0, 0, 4, 3. Now we go to 0, 0, 3. And specifically you can say k is 1. Or when L left is 1. So 0, 0, 3, 1 is what we're looking for now. Okay. Oh, there we go. Yeah, the one on the right works. Left is 1, so k minus left minus 1 is 0. We should get a 1 there. That's, oh, I'm sorry. No. K minus, which is 3 minus 1 minus 1 is 1. So this is 2 characters. Those do match, right? They're exactly equal to each other. EA is equal. GR to RG, though, should be also true, right? This one on the left side. So this is left 0, and it's 0, 0. K, I think, is also 0. No, K is 2. It's 0, 0. K is 1. 0, 0, 1, 0. So 0, 0, 1, 0 should also give us true. Zero, 0, 1, 0, way up there. 0, 0, 1, 0 doesn't give us true. Okay, why not? The 0, 0, 1, 0 is okay. This is like some in-depth debugging here. It's tedious debugging here. 0, 0, 1, 0 is, K is 1, means there's 2 characters we're looking at, and left is 0 means we're gonna try to match 1 character on one side, split on one side. Okay, so G matches with the other G, and R matches with the other R. So this is the second one. Should be true and true. So we got the first one is false, which is incorrect, and the second one is true, which is interesting. So A of left plus 1, B, which in our case we said is 0, 0, 1. So A of 1 and B of 0 match with 1 minus 0 minus 1 and 0. So that means that this R matches this R, right? And then we're trying to say that this G matches this G, but that didn't work out. Oh, because it's not N. Oh, that's why that is wrong. I didn't think about that. Because we're looking at subsections of the strings, not always starting from the end. So that's why my N minus 1 is incorrect. I didn't even think about it. It's a logical error. So shame on me. This should be B. No. This should be, so wherever B is starting plus left plus 1 characters, that puts you off the edge of B, and then you subtract, or excuse me, K is the number of characters in the string. K plus 1 is the number of characters, and we subtract left plus 1, which is left minus 1, which just gives you K minus left. Got it. That's the issue, I think. That was my mistake. That's a pretty big mistake too. Oh, now we're correct. Yeah, man. There's a lot of ways to make errors. See, this is why I greatly prefer the recursive solution, just because coding it's so much easier to think about. It's like, you could do the DP one, but even the DP one is pretty involved. Like, as you saw, it took me forever to get the DP one correct. Let's try all these different cases here. So I just wanted to just use a little bit less memory. Are we still correct? Let's find out. Hey, there we go. Use a little less memory and just be a little bit more efficient. So 98, almost 98%. Okay. There we go. Just ever so slightly more efficient. Yeah. You really gotta think that through, though. Excuse me. And what happens if we do this? Is this still right if we do this? I think this is wrong if we do it this way. Yeah. You have to do or equals. You can use an if statement here too, but it's kind of the same thing. So I guess if you use an if statement, you won't make these calculations first. There might be a slightly more efficient way to write this code. Like that also could be something I'm missing. You can also do this. Actually, this is probably even better. Slight optimization. Yeah, this is kind of interesting. Is this an optimization? I guess we'll find out. Not really. Because it uses two fewer booleans, and then also kind of puts calculating those inside of a what they call a. Actually, could do this. This terminates early. In some cases, so it's a little bit more efficient. Nope, that was actually less efficient. Or I don't know if it's really. I don't know. Maybe. Yeah, I don't know. We can go back to what we had. I think what we had is better. It's a little more clear what's happening. Assuming it's clear at all. Assuming it's clear at all. See, I spent a lot of time on this. We could go to the next thing. Yeah, not bad. But yeah, as I was saying before, is like this is almost like an order of magnitude faster than it's like 10 times faster than using the recursive approach, which is kind of a big deal. Asymptotically, it's not much faster, but like if you're dealing with small windows, small runtimes, I guess it matters. Could matter. Anyway, obviously this is like competitive. There's like which solutions are faster, that kind of thing. I don't know if I guess you cut these out too and make these a little bit faster. I'm wondering also if you can cut out some of these calculations and make it faster doing that too. You can add 1 to left and then subtract 1 where you see left. You can't avoid this one. Yeah, I don't know, everywhere there's always going to be like adding and subtracting stuff, I guess. Can be slightly optimized by writing an integer that's left plus 1, but then you also have left minus 1 here, so I don't know. Well, yeah, I guess. I mean, I guess if you parenthesize this left plus 1 here, it's definitely way more additions if you. So if you make left plus 1 here, it's 1, 2, 3, 4, 5 calculations over here, but then you have to modify 1, 2, 3 other calculations. Yeah, so let's try that. Let's do that. So now you subtract 1 from left here. Let's add 1 here. Subtract 1 here. Leave this here. Leave this here. And these all disappear. Okay. If I got the time limit exceeded. Oh no. Uh-oh. Oh, it was -1, not +1. I'm blind now. There we go. Trying to just squeeze out every last drop of efficiency I can get. I don't know, this is probably as good as we can get. I mean, let's not go crazy here. Let's not go crazy. Yeah, pretty interesting. Anyway, we're getting a little bit too much here. So, all right, what we're gonna do is say thank you for watching. That was supposed to be a quick look, not another hour and 40 minutes. So yeah, that's that problem as a dynamic programming solution. Not too complicated, not too bad, but there's not always such a simple translation from one to the other like that. But obviously the reason it's like I said, it's a lot faster because we can allocate the memory directly. We can allocate the memory directly, write. The code itself is kind of concise. It's very concise, just 4 loops. It's very clear. It's quartic and cubic memory, quartic routine. Don't need a container. Don't need tuples. Don't memorize anything. Excuse me, it's about 10 times faster, roughly. I don't know what else to say, or maybe not. It's more like eight times faster, I'd say. So, yeah. All right, I'm gonna move on. Thank you for watching. Talk to you soon. One of the challenges, though, that I struggle with this before I go is like, what's really challenging is like being able to convert from one solution to the other is not so obvious. Like it's usually relatively easy to write the recursive version. The dynamic programming version can be quite challenging, as you saw. As you saw, it was pretty. Yeah, I mean it's not too bad, I guess. Depends, maybe. Kind of depends. Yeah, it was interesting. There might be a way, and I don't know this. I don't know. There might be a way to even optimize the memory even more. Don't necessarily need to use all of the. Like, it's not obvious to me that you need to use cubic memory there. I think you do, just because of how it's been structured, but I could be wrong about that. Not necessarily sure if you need to use cubic memory. But anyway, so yeah, thanks again for watching. Talk to you soon. I'm actually gonna take a break for a minute or two, and then probably take a break for a minute or two, and then probably actually more than a minute or two of a while. Take a break for a while. And then come back to take a look at another problem. I think that'll be the plan. So yeah, thanks again. Take care.